Okay, today we're going to talk about some definitions that I think a lot of you already know some of these, but we got to be careful when you define stuff. Okay, so first of all, let's see if you can figure this one out. Two lines that do not intersect are called. Raise your hand if you think you know. Raise your hand. Raise your hand. Yes, sir.
Parallel line.
Okay, good. That's one of them. Actually, there's another type. Yes.
Skew lines.
Skew lines is correct. Turns out there are two types. They could either be parallel or skew. So we're going to then give you the definition for each of these. See if you guys know the difference, what the differences are. Okay. Does anybody already know what they are? Not quite. Okay, write this down first. There are two lines. If you have two lines that do not intersect, they're either parallel or skew. Okay, and we're going to define these carefully so we can figure out the difference between. Figure out the difference. Okay. Okay, let's start with parallel lines. Can somebody tell us what the? Oh, sorry. Hold on. Here we go. Sorry. So then, anyone know how do we define parallel lines? Anybody know the definition of parallel lines? Raise your hand. Yes, sir. Oh. Who won? Anybody? Want to guess? Yeah. Okay. Try.
Two lines go to the same plane that never intersect.
Exactly right. There are two parts for this. Say it again. Two lines. What?
The same plane.
They have to be in the same plane first. Very good. So here's a notation for parallel lines. First of all, they have to be coplanar. They have to be in the same plane, and of course, they do not intersect. So if you want to say, or if you want to prove that the two lines are parallel, can we just show that they don't intersect? Is that good enough? No, there are two parts in this definition. So you have to satisfy both of these parts. Not only can you show that they don't intersect, but you have to also show that they are on the same plane or coplanar. Does that make sense? So if you're going to actually see this later, we're going to show that the two lines are parallel and so forth. You cannot. It's not good enough to just show that two lines don't intersect. Okay. Are we good? All right. Next, then, what is the difference between parallel lines and skew lines? Can somebody think of what the difference might be? How do we define skew lines then? Two people? That's it? No one else. Kenneth, what do you think? Two lines that are not on the same plane, and of course they do not intersect. Exactly right. So the way we say this is, these are lines that are not coplanar, and of course they do not intersect. So again, this has two parts again. So do you see the difference? Right? Do you see the difference between parallel lines versus skew line? What is the difference between these? One of them, that they are in the same plane. The other, they're not in the same plane. Okay. So they could say something like, skew lines are lines that are neither parallel nor intersecting. Okay? That's another way of saying this. How is that even possible? How can a line be neither parallel or intersecting? Yes?
Neither parallel.
Right.
Just like one's going straight up, the other one's going horizontal.
Yeah, you could have, very good. You could have, for example, in this room, think about a vertical line in this corner of the room, right? Yes? And think about maybe a horizontal line in the back of the room. Does that make sense? Then these two lines are not in the same plane. First of all, see, it satisfies the first definition, part of the definition. Second part, they don't intersect. You see? Do they have to be horizontal and vertical, or could they be in any angles they want? It could be any angle, as long as they're not in the same plane. Okay? If they were in the same plane, then we don't call them skew. We call them they are parallel. Does that make sense? Any question? Does that make sense? Okay, good. There are a couple more definitions we need to know. Okay. But these definitions are pretty straightforward. What do you think? Oh, I'm sorry. What do you think Here's our next word that we need to understand. Parallel planes. What do you think? How do you think we're going to define parallel planes? One person? Leah, any idea? What do you think parallel planes are? This actually is really simple, turns out, when you define it. Yeah, exactly. It's just basically planes that do not intersect. Okay, is it possible? Again, here's the notation for it. You just draw two vertical lines close together, indicating it's parallel, and then planes. How can two planes be parallel? Is this possible? Yeah. The ceiling and the floor, right? Exactly. In this room, we could think about ceiling as a plane that goes on forever, and then the floor. Yeah, they will not intersect, correct? So these are two parallel planes. Easy enough? That's sort of easy to understand. Next, what about a line and a plane that are parallel? So this is actually, we define this. What do you think we mean by a line and a plane are parallel? If let me ask you this. We just talked about parallel planes. Let's go back to this. We just talked about parallel planes, right? How many lines can you draw? Let's think about the ceiling and the floor. How many lines can you draw on the ceiling? The plane on top. Infinitely many. How many lines can you draw on the floor? And pick any of those two lines. Are they going to intersect? Why not? Because they're in the planes that are, they're in the parallel planes. They're not, of course, they're not going to intersect, right? Since parallel planes do not intersect, anything that's inside the parallel planes will not intersect, right? Does that make sense? Now, keep that in mind. What about this? What do you think this means? A line and a plane that are parallel. Yeah. They don't intersect. So it's a line. If what? The line and the planes do not intersect. That's all it means. Right? So how would this look like? In terms of this room, I guess, again. Yeah.
A line on the floor.
Yeah, you could pick any line on the floor and then what?
The ceiling.
And the ceiling. Ceiling, imagine that ceiling is your plane, right? Will that line on the floor, right, intersect the plane, the ceiling? No. So that's an example of a line and a plane that are parallel. Easy? Very straightforward. Would you not agree? Okay. So knowing this, guess what we're going to have? A theorem is exactly right. All right, good. So here's our theorem from chapter 3. The first theorem from chapter 3. It says if two parallel planes are cut by a third plane. Okay. What does that mean? If two parallel planes are cut by a third plane? Can somebody? Yeah, here you go. What do you think, Ethan? Hmm. What do they mean by cut by a third plane? You think? Yeah, a third plane goes through both of them. Exactly right. So first, look at what we have here. We have two planes that are parallel, right? If two parallel planes are cut by a third plane, then the line of intersection. Anybody want to conclude? What do you think? One person knows? Two people see it? What do you think the line of intersection would do? 3 people? 4? 5? Okay, okay. How about Leo? What do you think? They're going to be parallel. Is correct. So that's exactly what this theorem is saying. Good. And here's a picture, and here's what's given to us. You don't have to write that out, I guess, but this helps us understand what this theorem is saying. Isn't that right? So this is in the book. You don't have to write it out, but we are going to prove this. So you have two planes that are parallel. Which one of these two planes are parallel? Plane X and plane Y. And plane Z is the third plane that is, right? I mean, that's, so plane Z is, plane X and Y are cut by that third plane Z. Does that make sense? Notice Z hits the two planes X and Y at L and N. Those are the lines, of course. When the two planes intersect, you get a line, don't you? And of course, we want to show that L and N do not intersect, or they're parallel. Okay. By the way, does this make sense? Would this be true, you think? How would you explain this to someone, maybe your younger brothers or sister, if they sort of asked you, what do they mean by this? What would you say? Instead of really proving it, how would you help them understand that, oh, if this happens, line L and N will not intersect? What would you say? Yeah. Jocelyn?
When the plane intersects, it's basically choosing a line, like or forming a line from each plane. And we already said that, like if the line is in the plane and it's parallel to any lines in the other plane that it's parallel to, so we sort of know that L and N are.
Exactly. L and N belongs to those two plane X, Y, which happens to be parallel. And of course, you could choose any line from X or any line from Y. They were never going to intersect. So of course, L and N are not going to intersect because they belong to X and Y. Correct? You're exactly right. So how would you, let's prove this. Let's take a look at the proof and let's see whether we understand. Okay? So I want you to note that, look at what's given to us. First, they said the plane X and plane Y are parallel, right? That's what's given. What do you think we have to say this? Plane Z intersects X in line L, and plane Z intersects Y in line N. Where are they getting that from? Go back to your theorem, I guess we'll go back. Which part of the theorem tells us that plane Z intersects X in line L, plane Z intersects Y in line L, N? Yes, sir? Exactly. If two parallel lines are cut by the third plane. So the two parallel line part is right up here. Plane X is parallel to plane Y. And our cut by the third plane is this, right? To say this is kind of showing you what they mean by cut by the third plane. Plane Z intersects X in L. Plane Z intersects Y in N. Is that okay? And of course, we want to show then L and N are parallel. Okay? In order to show that L and N are parallel, what do we need to show about L and N? Think back to your notes where we talked about definition of parallel lines. What do you think we have to say about L and N? First thing is what? How about Nico?
I don't know, but it's for.
Oh, sorry. Okay. Nico, what do you think? What can you read what we said about two lines that are parallel? It had,
They're coplanar
first of all, they have to be coplanar, then
and
they don't intersect. So if I want to show that L and N are parallel, I have to first show that L and N are. In this proof, I have to show that L and N are, first of all. There are two things you have to say about L and N. Do you know what that they are coplanar? That's the part where people forget to say because they just show that they do not intersect. Is that good enough? No, because if you just show that they do not intersect, then they could be skew. So we're not talking about them being skew lines, right? We're talking about these are parallel lines, correct? So we have to show first of all that L and N are coplanar and L and N do not intersect. Does that make sense? So let's see it. Let's look at how they do this. Does that make sense? So as we go about this proof, think about what they're showing. Okay, think about which part of the definition of parallel lines that they're proving here. First of all, they start with this. L is in Z, N is in Z. Where did they get that from? That's from the given. Very good. Oops. Okay, you didn't see that, right? Sorry. Let me move this up a little bit. That's fine. Okay, then that's given. Secondly, so what sort of comes natural after this? If L and N is in Z, what can you say next? Yes, one person knows. I want you to discuss with your group. Go ahead. I'll wait. What are we gonna? Two things. They know what to write next after this. After this given, L is in Z, N is in Z. What is sort of natural after? How about Emily? What do you think?
L is in X and N is in Y.
L is in X and N is in Y. What would your reason be? Because could we say that right after this? Oh, you want to say the given again?
Yeah.
Oh, okay. Yeah, we could do that. But why do you think we start off with this given? Then if they were going to do that, they could have put down everything that's given in the first step. So they're going to say something about, what does it mean, by the way? That L is in Z and N is in Z. That they're in the same plane. Is that important? Yes, why? Because we want to show that L and N are parallel. And in order to show that L and N are parallel, we have to first show that L and N are coplanar. So do you think we're going to say L and N are coplanar right now? Yes? What's the reason? How many put out of this, by the way? How many put that? Okay, very good. Katie, what do you think the reason is? Definition of coplanar is correct. It sort of comes from the first step too, doesn't it? Right? We said that L is in Z, L is in Z. Now we can say L and N are coplanar because of definition of coplanar. Right? Definition of coplanar means they're in the same plane. That's what we just said. Right? So guess what? This proves, or this shows, the first part of L and N being parallel. Correct? That L and N are coplanar. So that's good. Is that all? Is that all we need? Can we say now then L and N are parallel? No, we need the second part of the definition, right? Which is what? That they don't intersect. How are we going to do that? So guess, yes, Hannah, B. Plane X what? Plane X is parallel to plane Y. And that L is in X and N is in Y. Right? That's the other part of the given. Would you not agree? Okay. So the other part of the given, says that plane X and Y are parallel, and that L is in X and Y, N is in Y. So what? Using this, I claim to you then that we could say that the next step. So from the third step, what can we say after? What do we know about two planes that are parallel? Yes. They don't intersect. What about anything in it? Yes. Everything in it is parallel. So guess what? We're going to say L and N are parallel? No, we don't know that they're parallel yet. We just know that L and N what? Don't intersect. Because L and N are in X and Y, two parallel planes, right? Right? If two parallel planes don't intersect, then of course anything in it does not intersect. Right? What's the definition? Definition of parallel planes. Right? Is that okay? Since two parallel planes do not intersect, of course anything in it does not intersect. Even though there isn't a specific property or something, anything that we said it, right? We kind of say this, okay? We could include this. Okay? Now, so what? Now we're ready. Look at what it says. L and N do not intersect. So what? What are we going to say next? Now we're ready to say, anybody? Anybody? How about Kaylee? L is parallel to N. Why? Very good. This is the key. Why is it that we could now say L is parallel to N? One person knows? 2, 3, 4, 5, 6. Who haven't I called today? Grace? Why? Definition of parallel lines is correct, and which part of this proof tells you that L and N are parallel? Yes, Brandon. Step 2 and step 4. Why do we need that, guys? Why is it important to understand that we have to have step 2 and 4 to use the definition of parallel lines here? Yes, sir.
Because they need to be coplanar.
They need to be, first of all, be coplanar. Secondly, they have to
Not
not intersect. Does that make sense? So notice how they carefully, before they use the definition of parallel lines, they carefully state these two things that we need to say about line L and N. First of all, that they're coplanar, and secondly, that they do not intersect. Could we skip any of these steps for 2 and 4? No. Then they will not be parallel. Question?
On the test, you have to write steps 2 and 4.
You don't need to write it there, but do you see why they did it in the book? This is to help you understand why they did all these steps, right? Otherwise, sometimes some of you may not, right, go through it, maybe this is the part, like L and N are coplanar. Many times, because it's so obvious to us, just by looking at the picture, of course we know that L and N are coplanar, right? But we have to, again, in a proof, we have to do what? We have to state it, right? Does that make sense? Even though it may be really obvious to us, that's one of those things that you got to get used to. If you don't state it in the proof, then we don't know, even though it's obvious to us, right? This is the part of the game we're playing. You have to state it in the proof. Any question? Does that make sense? Hello? Yes? Okay, now we're going to switch the gear a little bit, and do you guys remember your intro classes? Maybe in summer or no? Okay. All right, maybe you learned this even not in it, maybe even before that. I don't know. How many people have heard of transversal before? Oh, good. What do you think a transversal is? These are actually, let's see if you could remember. These are a few years back. We talked about. Yes, sir, Kenneth. It's a line that cuts two parallel lines. Almost. That is a transversal, but that's not necessarily. That doesn't define every transversal. That is a special case. Does it have to cut or intersect two parallel lines? The answer is no. Anybody remember? It is basically, it sounds hard, but it's really nothing more than, yes sir, it is a line, but what does it? Extra cuts across what? Actually, yeah, exactly. It doesn't have to be parallel. It could be a line that intersects two or more. It doesn't have to be just two or more. And again, we have this word coplanar lines in different points. That is the definition of transversal. So a lot of you kind of remember this as a line that goes through two parallel lines, yeah, but that's not necessarily the everything. So you're exactly right. So here's an example of it. Take a look at this example. Oops, there you go. You have three lines, and of course, when three lines intersect this way, do you see how, Irene, you have to understand that they're intersecting at different points? If they were all intersecting at one point, then none of them are transversal. So here, when the two lines are cut by a transversal, how many angles does it form? 8. Forms 8 angles. Okay. So I have a line N, K, and T. Which one of these three lines is a transversal, you think? Raise your hand if you think you know. Okay, how many people think it's the line T? Raise your hand. Good. How many people think it's line N? How many people think it's line K? A lot of you said it's line T, right? You are correct. T is a transversal. Turns out though, technically N and K are also transversal. Does anybody know why? Yes. Yeah, they're gonna keep going, and N is going to intersect with K. Therefore, N intersects two other lines in different points. So does K, right? Does that make sense? But let's just make it simple. We're not gonna. Okay, let's not go to. So let's in this drawing. Do you see why T? They're indicating T as a transversal because you could see the actual intersection of those two, right? Lines. So good. So let's just think of T as a transversal for now. By the way, we could actually classify these angles, 8 angles that it forms, into 2 categories. First, imagine that this is your river and there's a water going through that river. Okay, how many angles are in the river, guys? 8 angles are in the. Oh, there are 4 angles that are in the river, and there are 4 angles that are outside the river. Guess what? These angles, 3, 4, 5, 6, that are in the river are called. Raise your hand if you think you remember. Yes. Interior angles is correct. These are the interior angles. Anybody have any idea what the angles that are outside the rivers are called then? If angle 3, 4, 5, 6 are the interior angles, Grace, they're called the exterior angles is correct. So here is the definition of interior angles. not definition, but here's the way they show us. Okay. So one way to remember, nice way to remember is remember that you could think of this as a river and T as your bridge or something. Okay. So in the river there are 4 angles. Those are the interior angles. Angles that are outside the river are the exterior angles. Is that okay? Does this ring a bell? Have you guys heard of these angles before? Now we're gonna classify them a little bit further. There are a special type of interior angles. These angles are called the alternate interior angles. Oops. I'm sorry? Yeah. So, alternate interior angles. How many people have heard of alternate interior angles before? Very good. Which one of these are the alternate interior angles? Since we're talking about interior angles, could it be angle 1, 2, 7, and 8? No, it's none of those. What do you think the alternate interior angles are? Give me the pair of the alternate interior angles. Yes, sir. Angle 6 and 3 is a pair. Those are the alternate interior angles. Very good. Anybody else? There's actually another pair. 6 and 3 and Brandon. 4 and 5 is correct. How do you think we're going to define then the alternate interior angles? Anybody? How would you define it? A lot of us know what they are, but how would you define? How do you think the book's going to define these alternate interior angles? Say it again. You're right.
They're opposites.
They're opposites. What do you mean by opposites? Opposite of what? Not quite. Anybody want to? How would you describe to a person that has never heard of interior angles before? How would you do? Yes, sir. What do you think?
Interior angles on the opposite side.
Opposite side of the what? What? Chili? Transversal is correct. But we forgot one more thing. Because if you say that, these are the interior angles that are opposite side of the transversal, then somebody might say what? What about angles 3 and 4? Aren't they opposite side? Aren't they interior angles 3 and 4? Aren't they opposite side of the transversal? Yes. So what do you have to say? Yes.
They're not adjacent.
Non-adjacent is correct. So that's why, please keep that in mind. That's why the book is really careful when they define these things. Because imagine if they left it out. If you leave that word out, then guess what? People might think that, oh, then 3, 4 are alternate interior angles. Or, right, 5 and 6. Does that make sense? So that's why we have that word in there. And that's why we'll be careful when we're defining these. If we could have alternate interior angles, book doesn't define them, but can somebody think of what the alternate exterior angles are? Can it? What would be the alternate exterior angle? Exactly, 2 non-adjacent exterior angles on the opposite side of the transversal. For example, 1 and what, class? 1 and 8, 2 and 7. Exactly. But we don't have those. Next sort of interior angles are called the same side interior angles. How many people have heard of same side interior angles? Very good. Why do you think they're called this way, and who thinks they know? First of all, who thinks they know which are the same side interior angles? How about Joshua? Do you remember? Josh, what do you think? Joshua, do you remember from back when you learned these things? You don't remember which are the same side interior? Let me give you a hint. It's called same side interior angles. Okay. Yeah, 4 and 6 will be same side interior. You're right. How about, who haven't I called? I haven't called Krista. What are the other pairs of same side? 3 and 5 are the same side interior angles. Very good. Okay. Anybody want to guess how we define same side interior angles? Yes, sir. They're supplementary. They don't have to be supplementary every time. No, not necessarily. And just by saying they're supplementary doesn't describe for a person which one of these are the same side interior angle. One. Okay. How about then, Michelle? What do you think?
There are 2 non-adjacent interior angles on the same side.
Same side of the transversal. Turns out they don't even tell you that. They skip that part. They don't tell us that they're 2 non-adjacent. How come they could skip that part? Anybody know why? Yes, sir.
Because there's no adjacent angles on the same side.
Yeah, exactly right. So if they're going to be on the same side, 3 and 4 are not on the same side of the transversal, so you don't even need to include that in there. You see what I mean? So you will find that in math, we try to make it as simple as possible. We do not include anything that is unnecessary. Okay, so so again here they don't put that in there. Okay, and lastly, yes,
Well, you know how we did talk about alternate exterior angles?
right?
When we were solving proofs, are we gonna be like?
No, you only are you could only use the ones that we have in the book. You're right. So I shouldn't even talk about it. I shouldn't have said anything. Okay, next. Guess which angles are next? Anybody want to guess or remember? Yes, sir.
3, 4, 5, 6.
3, 4, 5, 6.
And 3, 4, and 5, and 6.
Oh, 3 and 4?
Yeah.
We don't actually have name for 3 and 4. But we do have name for 1 and 5. Anybody know what we call these angles 1 and 5? Not only 1, 5, 3, 7 is this type. And then 2 and 8, 6 and 4 and 8. Yes, Hannah B. Corresponding angles is correct. What are corresponding angles? These are angles that are in, first of all, not all of them are interior or exterior, right? As a matter of fact, if one of them is interior, the other one has to be exterior. One person knows what corresponding angles are? 2? Jason, what do you think? Corresponding angles. Two angles that are on the same side of the transversal and what? Same side of the two. Yeah, I see what you mean. Yes. So this is how they actually. It's sort of hard to describe them, but this is how they describe it. They use the word corresponding positions. Okay. What they mean by corresponding positions? Well, look at angle 2 and angle 6. We know these are the corresponding angles, right? 2 and 6. Look at the position of this. Angle 2. It is on the right side of the transversal above one of the line, right? What about angle 6? 6 is also on the right side of the transversal above the other line. You see what we mean by corresponding positions? Does that make sense, guys? So these are the corresponding angles. Again, 1, 5. 1 is on the left. 5 is on the left of the transversal. 1 is above the line H. 5 is above line K, right? 3 and 7. Okay. These are corresponding angles because they're on the left side of transversal again, but they're below, right? The two lines. And does that make sense? Do you see what they mean by corresponding positions? Jason, do you agree in terms of what they're saying here? It's sort of hard to describe, isn't it? But this is what they mean by that, okay? Any question? Are we good? All right, good then.